Could you please tell me about yourself in brief?
Okay, so for the last 3 years, I have worked as a Java developer, mainly working on building backend system by using technologies like Spring Boot, Spring Security, and REST APIs, etc., etc. I have completed my graduation in computer science and engineering, and since then, I have worked on several complex projects like e-commerce clone, telecom applications, etc., etc. I took the lead in some of these projects and successfully delivered important feature to our clients. And this work has helped me grow my skills. And basically, I learned how to lead and communicate with clients by working on these projects.
Okay, so can you tell me about your recent projects?
Okay, so recently I worked on making an application for a retail business to keep track of their items. So basically, I use Java and Spring Boot for the backend and Angular for making the front end. The main job of this
Mhm.
application is to help the shop know how much stuff they have, handle orders, and update item counts automatically. We used Spring
Okay.
Boot to manage all the heavy duty tasks like talking to the database and making sure the different parts of the system can talk to each other easily. Right. For saving all the
Mhm.
data, basically we chose MySQL because it's good at handling lots of information quickly. And putting Spring Boot and React together was a bit tricky at first, especially getting them to
Mhm.
share information without any issues. So basically, that project helped me get better at building complete applications that can do a lot of things and are easier for people to use. So yeah, it was a great way to
Mhm.
learn about using both Spring Boot for the backend and React for the front end. So we just built. I mean, we were working on this project as a team. So my primary
Mhm.
task was to work on the backend only.
Okay. So,
Yeah.
what did you use for handling concurrent user in this project?
Okay, so I handled many users at the same time for this project uh, through the Spring Boot by using two main ideas, thread pools and doing things asynchronously. Okay, so thread pools
Mhm.
helps me limit how many things can run at once, so the server doesn't get overwhelmed. And doing things asynchronously means that the server can move on to the other task while waiting for something to finish. Okay, instead of just waiting
Okay.
around. So this way the server can deal with more users without getting slowed down. So that's how I
Mhm.
implemented. I mean, I handled the concurrent users.
Okay. So, can you please tell me the annotations of asynchronous functionality?
Okay, so rotation for asynchronous functionality. Okay, so for asynchronous functionality in a Spring Boot, basically I use async annotation, and
Mhm.
this tells the Spring Boot to run the annotated method in a separate thread and allowing the main process to continue without waiting for the method to complete. So yeah, yeah, that's
Okay.
the name.
Okay. How can you synchronize two Java process?
Okay, so basically, to make two Java processes work together smoothly, we can use things like sockets, okay, which let them send messages to each other over a network or a shared database where both processes can read and write information to coordinate, right? And
Mhm.
another way is through a shared file system where the process can
Mhm.
create, read, and write files to communicate, etc., etc. And we can also use logs to make sure they don't interfere with each other, right? So yeah, I think these techniques
Mhm.
help the processes to stay in sync and cooperate with each other. So yeah.
Okay, so moving to the next question, describe the key component of Java virtual machine architecture.
Okay, so basically it has three parts, right? The class loader, the runtime data areas, and the execution engine. Okay, so the class
Mhm.
loader loads class files into the JVM, right? And the
Mhm.
runtime data areas store data needed while the program runs, like memory for variables and code. And the last part, the execution engine actually runs the instruction in the class files
Mhm.
together. So these components lets us run Java program on any device that has a JVM, and these things basically make Java write once and run anywhere.
Okay, so can you tell me how the heap and stack memory areas differ?
Okay, so in the JVM, the heap and stack memory serves the different purposes, right? The heap is like a big
Mhm.
storage room for all the objects created by Java application. Okay, it's where the memory for all class instances and arrays allocated. This area is managed by the garbage collector, which cleans up unused object to the free memory. Okay, and
Mhm.
on the other hand, the stack is like a notebook stack for method calls. Okay, that stores
Mhm.
local variables and function call details. And each threads in Java application has its own stack and making it thread safe. Whereas the heap is shared across threads, while the
Mhm.
heap is for sorry, whereas the heap is shared across threads, and it's for used for dynamic memory allocation of the objects, and the stack is for static memory allocation, just tied up to the execution of methods.
Okay, so how does the Java enhance the performance of execution engine?
Mm, okay, so basically Java makes faster its engine by using JIT, just in time compilation. Okay, instead of slowing
Mhm.
down through bytecode one line at a time, JIT turns bytecode into the native machine code, right? Before it's needed. Okay, so this means that
Mhm.
once a piece of code is compiled, it can run quickly every time after that, just like programs made for a specific type of computer. Okay, also
Mhm.
Java uses smart ways to make code run faster, like removing parts that are not needed and making repeated tasks run more efficiently. Okay,
Mhm.
and this helps Java program run faster, almost as fast as if they were designed specifically for the computers they are running on. Yeah, so yeah, that's I
Mhm.
currently I know these two methods. I mean Java enhance the
Okay.
performance. Yeah.
Okay, so can you tell me how does the Java implement polymorphism?
So basically, Java uses two main ways to achieve polymorphism, which is the
Mhm.
ability for the same code to act differently based on what type of objects it's dealing with. Okay. First, if a
Mhm.
class overrides a method that comes from a parent class, so Java decides which versions of the method to use based on the actual object type, not on what the code says the object is. Okay. And this lets the same piece of code work differently with different objects. And the second, Java uses interfaces. Okay, which are like promises that a class will include certain methods, and yeah, this way a single class can follow different set of interfaces and acting in a
Mhm.
various way depending on which interfaces is referred to. So yeah, these are the two ways.
Okay, so can changing access modifier affect polymorphic behavior in overridden method?
Mm, yes. So yes, changing access modifier can impact how overridden
Mhm.
methods works in Java. So basically, if we override a method, we can't make it more private than it was in the present class. Okay. For example,
Mhm.
if a method in the parent class is public, so we cannot make the overridden method in the child class protected or private. Okay. Doing this wrong can stop the method from being overridden correctly, and it will just mess up the ability to use polymorphism. So polymorphism, let us use the same method in different ways, but if the access levels are not set correctly, okay, so it can cause errors
Mhm.
and prevent the program from running as expected.
Okay, so how does the super keyword play a role in polymorphism, especially in the context of method override?
Okay, so the super keyword in Java helps with polymorphism during method overriding by letting a subclass call a method from its parent class. Okay,
Mhm.
so when a subclass
Okay.
overrides a method but still want to use the version in the parent class, so it can use super to do so. Okay, And this is
Mhm.
useful for adding to the behavior of the inherited method, not just replacing it. Okay, so
Mhm.
super allows both the original and the new method to work together, and uh, uh, enhancing the way a program can use different versions of the same method.
Okay, so can you explain how Java handle access visibility in subclasses?
Okay, so yeah, I can tell you. So basically, in Java, when one class inherits from another, how it
Mhm.
can see or use the parents class stuff depends on access level. So there are there are four access level: public, protective, and no specific keyword, and private. I mean default and private. Okay,
Mhm.
anything marked public can be seen anywhere, whereas protected things are seen in subclasses or in the same package. Okay, and
Okay.
the default one, I mean, where we don't use any keyword. So this means only classes in the same package can see it, and subclass outside the package cannot. And the private things cannot be seen by subclass at all. When a subclass overrides a method, so it can make it more open,
Mhm.
but not more restricted. So yeah, this setup helps keep things organized and definitely secure in Java programs.
Okay, so moving to the next question. How does polymorphism benefits the Java collection framework?
Okay, so polymorphism helps the Java collection framework by letting it treat different types of collections the same way. Okay, for
Mhm.
example, whether we are using an array list or a linked list, we can work with both using the list interfaces. Okay, this means we can
Okay.
switch from one type to another without changing much of our code. Okay, so it makes our code more
Mhm.
flexible and easier to manage, and plus it allows the collections to use a common set of methods and making it simpler to work with and understand. So yeah, that's how we can use polymorphism. I mean, we can take benefit of polymorphism.
Okay, so in collection, how does the hash set ensure that are no duplicates?
Okay, so basically, a hash set in Java makes sure that there are no duplicates by using something called a hash table. Okay, so when we try to add a new item, hash set calculates a special code for it, and this special code is nothing but a hash code. Okay, so this code decides where in the hash table the item should go. Okay, if there is already an
Mhm.
item with the same code in that spot, so the new item won't be added because it's considered a duplicate. So yeah, this way headset quickly keeps only unique items without having to look through each item one by one.
Okay, so can you describe how hash code and equals work together in a collection?
Yeah, sure. So basically, Java collections, hash code and equal methods work together to identify unique objects. Okay. So when an object is added to the collection, hashcat basically calculates hashcat method basically calculates a hash code that determines where the object should be placed, right? And if two objects have the same hash code, then equal method is used to check if they are truly equal. If equal methods returns true, then the objects are considered duplicate. And this combination will tell that each object in a collection, like a hash set, is unique by its data, not just by its memory address,
Mhm.
and allowing efficient storage and retrieval of objects.
Okay, so can you explain how does Java 8 Stream API enhance collection process?
Okay, so yeah, sure. So Java 8 Stream API makes working with collections much easier and more efficient. So what it's do is it lets us perform operations like
Mhm.
filtering and sorting and converting items in a collection with just a few lines of code. And it also supports doing tasks in parallel, which means now it can process large amounts of data faster by using multiple process cores. So yeah, this makes our code not only shorter and cleaner, but also faster and more powerful, especially for big collections.
Okay, so what are the issue of using a mutable object as a key in a hash map?
Yeah, so basically, by using a mutable object as a key in a hash map, can lead a lot of issues, right? If the object
Mhm.
state changes after it's placed into the hash map, so its hash code may changes as well. right? And this means the hash map might not find the object later because it's looking in the wrong place based on the original hash code. Okay, so yeah,
Okay.
as a result, then we can lose access to that entry and making it behavior unpredictable, right? And so that's why it's recommended to use immutable objects as key to ensure consistent behavior as their hash codes remains constant and ensuring the integrity of the hash map structure and the entries. So yeah.
Okay, so can you describe a complex problem you solve using a Java collection?
Okay, so I solved a problem where I needed to find all unique pairs of numbers in a list that add up to a certain
Mhm.
number. Okay, so in that
Okay.
case, I used a hash map to quickly check if I already had seen the number needed to complete a pair. Okay, for example, let's say if my target sum was 10, okay, and I had
Mhm.
a 3. Then I checked if I had a 7 already, and if I did, I added the pair 3 7 to an array list because it's a match, right? And this way, by
Mhm.
combining hash set for the fast searches and array lists to keep track of the pairs, I efficiently found all unique pairs that added up to the target sum. So
Mhm.
that was one of the problem in my project that I solved by using uh, the Java collection.
Okay. So, can we create a server in Java application without using a Spring framework?
Yes, we can create a server in Java without using the Spring framework. So basically, in Java, has built-in tools like the server socket class that let us listen
Mhm.
for and handle network requests. Okay, and by writing
Mhm.
code that sets up a server socket to wait for connections on a specific port, we can accept the connections from clients, read their inputs, and send back responses. Okay, so
Okay.
yeah, this methods requires more work on handling the details of network communication by ourselves. But it's a direct way to build server with just Java's standard features. So yeah.
Okay. So, how would you deploy a web application using a servlet container like Apache Tomcat or Jetty without Spring?
Okay, so to deploy a web application using servlet container like Apache, Tomcat, or Jetty without Spring, first I think we need to first create a war file that contains
Mhm.
a servlet and other web resources. Okay, then we have to
Okay.
configure our web application using a web.xml file to specify the servlet mappings and other settings. Okay, then in the end
Okay.
we have to deploy the war file to the servlet container. Okay, and to the servlet container by placing it in the appropriate directory or using a
Mhm.
containers management interface. Okay, so the servlet container will automatically handle the deployment and making our web application accessible via web browser.
Okay. So, can you provide an example where auto configuration simplifies development?
Okay, so yeah, auto configuration makes setting up projects much easier. For example, in a Spring Boot application, just by adding Spring Boot starter web, basically Spring Boot automatically sets up a Tomcat server, okay, for us, and it prepares a basic for building web applications and deals with common errors. Okay, so normally doing all these would require manually configure each component, which can be time consuming and prone to mistakes. Okay, but with
Mhm.
auto configuration, we can skip most of the setup work and start working on what our application needs to do it right away. So yeah, this
Okay.
was the example of how.
Okay.
Yeah.
Okay. Okay. So, can you discuss a scenario where you have to override the default auto configuration provided by Spring Boot?
Scenario. Okay, so
Mhm.
actually, yeah, I haven't overwritten yet, so I'm not sure on the scenario side.
Okay. Okay. No problem. So, but do you know how can we achieve it?
Yes, I know. So basically, auto configuration in Spring Boot works by automatically setting up our projects based on the libraries
Mhm.
we add. Okay. For example, if we include a database library, Spring Boot configures a connection for us And this is done using by using spatial annotation in our port, and that tells Spring Boot to scan for libraries and set things up accordingly. So we can customize these settings through configuration files or code, and this way, much of initial setup work is done for us, and it will be letting us focus on building our application. So that's how we can achieve.
Mhm. Okay, so imagine you notice that a Springboot application you are working on is significantly slower in production than in development environment. Okay,
Mhm.
so how would you go about fixing the problem?
Okay, so slower in production, but faster in
Mhm.
development. Okay. So when a Spring Boot application is slower in production than in development, so I
Mhm.
can start by checking the logs for errors or slow
Okay.
processes like why it is slow, right? Then definitely I would use monitoring tools to track the performance metrics like memory usage, CPU load, and response times, etc., etc. Okay, and then I
Mhm.
would compare configuration between development and production to find the differences, and also I will check if the database queries are optimized and if external services used in the
Mhm.
production are affecting performance. So yeah, based on these findings, I'll make my final decision, and definitely these things will improve my application in production.
Okay, so now imagine that you need to migrate an existing application to use a new
Mm,
database schema in Spring Boot without downtime. Okay,
okay.
so how would you plan and execute this migration?
Okay, so in order to migrate an application to a new database schema in Spring Boot application without downtime, first
Mhm.
I would create a new schema that works with the old and new versions, right? Then I would update
Mhm.
the application to support both schemas, and slowly and gradually, I'll be shifting from older to new. Okay. So by
Mhm.
using database, I'll use database migration tools as well, like Flyway or Liquibase for control changes. And then
Okay.
finally, I would test in a staging environment and then deploy the updates with the new schema in production. And parallelly, I will ensure the continuous operation throughout the process.
Okay, so have you heard about circular dependency?
Yes. So basically, circular dependencies occur when two or more components depend on each other directly or indirectly,
Mhm.
and will be creating a cycle. So this situation can lead to problems like infinite loops where each component waits for the other components to complete, or issues with initialization as there is no clear starting point for any of the components, right? And it's a
Mhm.
common issue in software development that requires carefully designed to avoid or resolve. So yeah.
So, okay, how would you address the issue of circular dependency?
Mm, okay, so actually, I know about circular dependencies, and I told you.
Mhm.
But addressing the issues, actually, I haven't addressed any issue yet, so I'm not sure on this.
Okay, okay, no problem. So, moving to the next question, discuss the specific security challenges associated with using WebSocket in a Spring Boot application.
Okay, so WebSockets in a Spring Boot application faces security issues because they keep a
Mhm.
constant connection open between the user and the server, unlike the regular web pages. Okay, and this can lead to
Mhm.
the risk like attackers hijacking these connections to intercept or send fake messages. Right. Also, without the usual security
Okay.
checks we have for web pages, and it's trickier to stop
Mhm.
unauthorized access, right? And to
Okay.
keep things safe, it's also important to make sure only the right people can connect, and to encrypt the data being sent back and forth. So yeah, that's
Mhm.
all about WebSocket.